Hello everyone, welcome. We are in second chapter, it is inter-process communications. Here data representation. So at the physical layer of network architecture, data is transmitted as analog signals which represent a binary stream. So in OSI reference model we have 7 layers. In that, the first layer, it is a physical layer. Here in physical layer the data is transmitted in the form of analog signals or analog signals, and the next layer, it is data link layer. Here the analog signals are converted into frames, and in network layer these frames are converted into datagrams. Okay. So here at the physical layer of network architecture, data is transmitted as analog signals which represent a binary stream. Okay. So this binary stream is transmitted in the form of analog signals. So at the application layer, the more complex representation of transmitted data is needed in order to support data types and data structures provided in programming languages. So here data types may be strings or integers or floating point, like that, or data structures may be arrays or records or objects, or okay. So here there is one example. The two processes, process 1 on host A and process 2 on host B. Host A is a 32-bit machine which uses big endian representation. So big endian representation is, what is that? The MSB or most significant bits are stored in higher memory location, and little endian, it is most significant bits are stored in lowest memory location. Okay. So here host A is 32-bit machine and host B is a 16-bit machine. So host A follows big endian representation and host B uses little endian representation to send and receive data. So process 1 sends data to process 2. So here there are 3 schemes. Okay, process 1 sends data to process 2. So process 1 is 32-bit and process 2 is 16-bit. And here there are the 3 schemes. Prior to issuing send operation, process 1 converts the value of integer to 16-bit, that is little endian representation. So prior to issuing send operation, so before issuing send operation, process 1 can convert the value of integer, the sending value of data, to 16-bit little endian representation. Or there is second scheme, that is process 1 sends 32-bit big endian representation. Upon receiving the data, process 2 converts it to 16-bit little endian representation, because process 2 is on host B and host B is a little endian. It follows little endian representation. And third scheme is to exchange data in an external representation. Data will be sent using this representation, that is external representation, and data received will be interpreted using external representation and converted to the native representation. Okay. So next one, data encoding. General purpose distributed applications require a universal platform independent scheme for encoding the exchanged data. So there exist network data encoding standards. They are, so at the simplest level, an encoding scheme, that is external data representation or XDR, allows a selected set of data types and data structures to be specified, and data marshalling and unmarshalling are performed automatically. So at the simplest level, that is a external data representation, it allows selected set of data types and data structures to be specified, and data marshalling and unmarshalling. So what is that? Data marshalling is converting the data values to an external representation. So converting data values to external representation is called data marshalling, and back to original form it is unmarshalling. So marshalling and unmarshalling at the simplest level. Next one, at the higher level standards such as ASN1, that is abstract syntax notation number 1 is used. ASN1 is an OSI standard that specifies a transfer syntax for representing network data. For network data, it specifies that transfer syntax. So it transfer syntax for network data. So at even higher level, the XML, it is extensible markup language, is used, is a data description language. XML is a data description language for data sharing among internet applications using syntax similar to HTML. So XML is a language, it is similar to XML, and XML is a language similar to HTML. This XML is a data description language, okay, for used for sharing among internet applications. So these three are data encoding standards. Data at the simplest level it is XDR, external data representation, and at higher level ASN 1, that is abstract syntax notation number 1, and at even higher level it is XML or extensible markup language, okay. So there is a concept of text based protocols. What is these? What are these text based protocols? Protocols which exchange requests and responses in the form of character strings are called text based protocols. So where the communication is done in the form of character strings. Communication means request and responses are done in the form of character strings. So these protocols are called text based protocols. There is one more, request response protocols. Request response protocol. In this protocol, one side issues a request and awaits a response from the other side. So subsequently another request may be issued. Protocol proceeds request and response until desired task is complete. So in this protocol, one side issues a request and awaits, that is client side. Client side always issues a request and waits for response, and subsequently it can issue another request, and this follows, request and response follows until the desired task is complete, okay. So there is a concept of event diagram. You know what is event diagram, and one more, sequence diagram. An event diagram can be used to document the detailed sequence of events and blocking during the execution of a protocol, okay. So here this is an event diagram. Here process A and process B. So here the solid line interval, says the process is active. The solid line interval along the execution line represents a time period during which the process is active. So here solid line, process A, the solid line represents the process is active. The broken line or dotted line represents the process is blocked, okay. So here the dotted line represents process is blocked. Process A, initially it is active and then it is blocked, but here process is initially active, process B is initially active and then it is blocked, okay. So this is an event diagram. See here in this case, process B, see this process B issues a blocked receive operation in anticipation of request 1 from process A. So process B issues blocked request 1, blocked receive operation in anticipation of request 1 from process A, and process A issues blocked request 1 using a non-block send operation. So first process A issues a non-blocking send operation because it is the process is active here, isn't it? Initially it is active. Initially process give A issues a non-blocking send operation, and then subsequently a blocking receive operation in anticipation of process B's response. Okay. The arrival of request 1 reactivates process B. See, process B is blocked here. So when it receives request from process A, it unblocks the process. Okay, the process is unblocked. So the arrival of request 1 reactivates process B, which processes the request before issuing a send operation to transmit response 1 to process A. So process B then issues a blocking receive for request 2 from process A. The arrival of response 1 unblocks process A, which resumes execution to work on the response, and it issue request 2, which unblocks process B, and similar sequence of events follows. Okay, so here process A issues request 1 and unblocks process B. So process B it operates the request 1, it processes the request 1 and sends the response to process A, and process 1 was blocked, and process B will, the response will unblock the process A, and process A will, it will execute that response, and again it will send request to process B and unblock the process B. Okay, so here this is an event diagram. So this is an event diagram of HTTP session. HTTP session, here web server and web browser processes are there, and here web server process is a process. See, first one, this is web server process. So here it constantly listens for incoming request from web browser process. So web server is a server, isn't it? So it constantly listens to any request from web browser. So a web browser process makes a connection to the server, then issues a request in the format dictated by the protocol. So the server processes the request and dispatches the response to the browser process. So upon receiving the response, the browser process parses the response. That means it will interpret the response and displays the document. See, here web browser constantly listens, that means it is blocked. Initially web server is blocked, so it constantly listens to any request from web browser. So web browser issues a request to web server and unblocks the server. So web server processes the request from web browser and it sends the response to web browser. So first of all, web browser sends request and it blocks the operation. So, and the web server sends response to web browser and it unblocks the process, and web browser will accept the response and it will process the response. That means it will interpret the response and it will display the document. Okay, so this is an event diagram for an HTTP session. So there is one more concept, it is a sequence diagram. Sequence diagram is a simplified form of diagram used to document inter-process communications. So it is simplest form of form of diagram used to document inter-process communications. The execution of each participant of a protocol is represented as dashed line and does not differentiate between blocked and executing state. Okay, but in event diagram, blocked state is represented in the dotted line and executing state is represented using the blocked line. Okay, so here executing the process is represented as the solid line and the blocked state is represented as dotted line. Okay, But here in sequence diagram there is no difference, okay, between blocked and executing state. So this is a sequence diagram. This is a sequence diagram for basic HTTP. Okay, process A and process B. Process A and process B. Process A sends request to process B. Process B sends response to process A, and again process A sends request to process B, and process B sends response to process A. So there is no difference between blocking or blocked or unblocked state, or blocked or active state. Okay, so here next one is a sequence diagram for HTTP, web browser and web server. Web browser sends HTTP request, web server sends HTTP response. So here it is sequence diagram, that is simplified form of diagram. There is no difference between blocked state and active state. Okay.